Hi guys, welcome you all to my channel Explore Edu to Teach.
Next topic that we'll be learning in control system is the Nyquist plot. Already video lectures on Bode plot, root locus is uploaded on my YouTube channel playlist in control system, so you can go and watch it from there. So the next topic is going to be Nyquist plot, which is again a particular topic which deals with the stability of the system. So if you want to find out the stability of the system, there are various techniques, one of them being Nyquist plot. So if you like this video, do not forget to like, share, subscribe to my YouTube channel. Also the diagrams, the shorthand videos are already uploaded on my Instagram page. It's going to be really helpful for you, those summary videos, those pictures which are going to help you in your revision of your exams. So please check out the links given down in the description box of my Instagram page, which also reads Explore Edu to Teach. If you like that particular page, do not forget me to follow on Instagram as well. So let's begin up with Nyquist plot. So what are Nyquist plot? Nyquist plot, as I said, they are a continuation of polar plots. So we have learned about polar plots. So if you just go one step ahead, it gives you Nyquist plot, and Nyquist plot gives you the stability of the closed loop system, as I already mentioned. So let's try to understand what is a Nyquist plot. So as I told you, a Nyquist plot is nothing else than a continuation of polar plot. In terms of a Nyquist plot is a mirror of polar plot. So if you see, it has this plot in which the origin is not included. The radius goes from minus infinity to plus infinity. So that is the Nyquist plot. So Nyquist plot is the mirror of a polar plot. It does not include the origin, and the radius goes from minus infinity to plus infinity. I hope I am very clear with this. So the same thing is given down below. There is nothing new in that. We'll just go through it and you'll have a better understanding about the same. So the Nyquist plot, if you see, does not include the origin, and it includes from minus infinity to plus infinity. So how do I use Nyquist plot for my stability purpose? So this is very important. The shortcut formula is uploaded on my Instagram page. You can check it from there. So basically, n is equal to p minus z is a very important formula in Nyquist plot, in which n indicates the number of encirclements around minus 1 plus j0. So if you see, here minus 1 will exist somewhere over here, right? Minus 1 plus j0, there is nothing on the imaginary axis. It is on the negative scale axis. So basically, n is equal to p minus z, where n indicates the number of encirclements around minus 1 plus j0. Now, if it is in the anti-clockwise direction, it is plus 1. If it is in the clockwise direction, it is minus 1. P indicates the number of right-hand poles of a open loop transfer function, and Z indicates the number of right-hand poles of a closed loop transfer function. So if I have to talk about a Nyquist plot is nothing else than a continuation of polar plot, in which I have the mirror image of a polar plot. It does not include the origin, and it goes from minus infinity to plus infinity. I have the formula n is equal to p minus z, in which my n indicates the number of encirclements around minus 1 plus j0. It is plus 1 in anti-clockwise direction and minus 1 in clockwise direction. P indicates the number of right-hand poles of an open loop transfer function, and Z indicates the number of right-hand poles of a closed loop transfer function. Now this is my diagram of a Nyquist plot, and this was asked in the GATE examination itself. So we'll try to understand this diagram. How does this diagram work out? Okay, so basically a diagram is given to you. They are saying that g of s is stable. So what is g of s? G of s indicates the open loop transfer function. If I say that my g of s is stable, I can say that p is equal to 0. See, p indicates the number of right hand poles of an open loop transfer function. If my g of s, that is the open loop transfer function, is stable, that means the number of right hand poles of open loop transfer function will be equal to 0. So in the formula of n is equal to p minus z, definitely my value of p is equal to 0. Then I have this diagram. So the diagram which was given to you is over here. From this diagram, I am going to draw just the mirror image of it. So the diagram was given to you in this way. I am just drawing the mirror image of this in such a way. So if you just draw the mirror image of it, you will get this kind of diagram. So if you see in this, basically what was happening is my arrow is coming inside, but in the mirror image the arrow will be going outside. If you see, the arrow is coming towards the origin, right? So if I draw a mirror image of it, the arrow will be going outside. So this is the Nyquist plot. So basically what happens in a Nyquist plot is that we have to find out for which value of k my system is stable. So as I told you, in case of your Nyquist plot, only when your value of n is equal to 0, only when the value of your n is equal to 0, my Nyquist plot will be stable. So if I just consider this diagram, there are different points such as 0, minus 0.2k, minus 2k and minus 8k. So what happens is that, let us try to assume that minus 1 is over here between 0 to minus 0.2k. So in that case, I can say the number of encirclements, 1 is in the clockwise direction, I can take minus 1. The other one is also in the clockwise direction, I can take as minus 1. Hence total is n is equal to minus 2, but my system is only stable when n is equal to 0. Hence my stability does not exist between 0 to minus 2k. Next I am considering from minus 0.2k to minus 2k. If you see in this, if I consider the minus 1 between this, then one encirclement is in anti-clockwise direction, the other encirclement is in clockwise direction. That means n is equal to minus 1 plus 1 is equal to 0. So that is very important. Now we are going to draw this plot. The g of s is given to you. You have to find out the plot from it. So how do you draw a plot of such questions? Just write down s in terms of j omega. The magnitude is 1 upon omega and the angle is minus 90. If I put the value of omega as 0, I get magnitude as infinite, and if I put the value of omega as infinite, I get magnitude as 0. Similarly, the angle is minus 90 and minus 90. So it goes from omega is equal to 0, the magnitude is infinite, and at omega is equal to infinite, the magnitude is equal to 0. So if you see minus 90, that means it is going to be only on the negative y-axis. So it's going to be from omega is equal to 0 to omega is equal to infinite. I hope I am very clear. So there are certain tips in order to how to quickly draw the Nyquist plot for a particular transfer function given. So these tips are given to you over here. If you see, if the particular transfer function is type 0 order 1, the diagram will be this. Similarly, for different types of type and order of the transfer function, I get this Nyquist plot. So I will just show you how to use those tips very quickly in order to draw the Nyquist plot. If you see, the given Nyquist plot is given as 1 upon, now this is only applicable, I repeat, this is only applicable when my numerator value is equal to 1. If my numerator has certain s terms, I cannot use those tips and shortcut tricks over here. So I'll just show you how to use this shortcut trick and get the polar plot, Nyquist plot, and how to do it via formulated way also. So the open loop transfer function is 1 upon s into s plus 1. So it's a type 1 order 2 system. It's already covered in my YouTube channel videos, how to understand the type of the system, the order of the system. So it's a type 1 order 2. So if you just consider, the type 1 order 2 is this kind of plot. It starts from the negative y-axis to the negative x-axis. So if you see over here, it comes from negative y axis to the negative x axis. So this is my polar plot straight away. And I told you Nyquist plot is nothing else than the mirror image of it with the arrow going outside, because the polar plot arrow was coming inside. Now if I go to draw it in the formulated kind of way, I just put s is equal to j omega value, and here I put the angle. So when I put the value of omega as 0, I get magnitude as infinite. When I put the value of magnitude omega as infinite, I get magnitude as 0. And the angle is always and always minus 90 in this term, because tan inverse of omega is 0. Hence I have minus 90, 90 goes up. And when omega is infinite, I have 90 and 90, that is minus 180 degree. So the diagram goes from minus 90 to minus 180. So I hope I am very clear with this. So these videos are going to be really helpful for you. If you like this video, do not forget to like, share, subscribe to my YouTube channel. Follow me on Instagram as well. Thank you so much guys. God bless.